The physics of airplane flight. Ever wondered how planes soar through the skies? Let's dive into the physics behind it. The wings generate lift by taking advantage of airflow, creating a pressure difference above and below. Jet engines push airplanes forward, using Newton's third law. For every action, there is an equal and opposite reaction. Four fundamental forces govern flight: lift, weight, thrust, and drag, working in harmony. Pilots skillfully manage these forces through navigation and control of the aircraft systems. As speeds increase, aerodynamic heating occurs, which pilots must account for in their flight plans. Bernoulli's principle plays a key role, explaining how faster airflow reduces pressure, lifting the plane. Wings are designed with airfoils to maximize lift and minimize drag, creating efficient flight. Flaps increase surface area during takeoff and landing, enhancing lift at slower speeds. Altitude affects air density. Higher altitudes provide thinner air, impacting lift and performance. Turbulence can disrupt smooth airflow, impacting a plane's stability and control. Weather conditions like wind speed and direction are crucial for safe flight operations. Maintaining the aircraft's center of gravity ensures optimal stability during flight. Ailerons control rolling movement, allowing the aircraft to turn effectively in the air. Turning requires balancing lift and weight, creating a banked angle that steers the plane. Pilots use control sticks and pedals to manipulate various flight surfaces for precise maneuvers. Drag arises from friction and pressure differences, countering thrust and requiring design optimization. During descent, increased drag slows the aircraft, requiring careful throttle management. Landing requires precise calculations of speed, altitude, and descent rate to ensure a safe touchdown. Reverse thrust slows the aircraft post-landing, enhancing safety during braking. As lift increases, so does lift-induced drag, demanding a balance for efficient flight. The flight envelope defines an aircraft's operational limits regarding speed and altitude. Different aircraft designs optimize for specific missions, showcasing diverse aerodynamics principles. Wind tunnel tests help engineers understand airflow and improve aerodynamic efficiency. Aircraft design continues to evolve, driven by advancements in physics and technology. Flight simulators allow pilots to practice and understand flight dynamics without leaving the ground. Understanding aerodynamics is essential for both pilots and engineers for safe aircraft operation. Jet engines operate on the principle of combustion, turning fuel into thrust for flight. At cruising altitude, airplanes require less thrust, optimizing fuel efficiency for long journeys. Stabilizers maintain balance, providing control over pitch during various flight phases. Monitoring altitude and speed helps pilots make informed decisions for a safe flight. Understanding atmospheric layers helps predict weather and its impact on flight performance. Flying through storms requires skill in managing sudden updrafts and downdrafts for safety. Takeoff dynamics require careful control of thrust and lift to break free of gravitational pull. Turbulence is measured and plotted, helping pilots navigate safely through rough air. As speed increases, drag also increases, requiring careful throttle management to maintain efficiency. A vertical climb demands significant thrust and lift, showcasing an aircraft's powerful capabilities. Modern navigation systems integrate multiple factors to ensure accurate course tracking. Innovative design techniques reduce drag, allowing for faster, more efficient aircraft. Coordinated takeoffs and landings are critical for airport efficiency and safety. Automated flight systems enhance pilot decision-making, allowing for smoother operations. The interplay of forces shapes every stage of a flight, from takeoff to landing. The Coriolis effect influences flight paths, particularly on long-distance journeys. Regular maintenance ensures aircraft are in optimal condition, making flying safer for everyone. Control surfaces adjust aerodynamics, providing pilots with the ability to maneuver effectively. Higher altitudes can cause engines to perform less efficiently, impacting overall flight. Every flight adventure begins with a well-executed takeoff, launching into the sky. Fuel efficiency is key to modern aviation, balancing cost and environmental impact. From the Wright brothers' first flight to today's jets, aviation has come a long way. With every flight, science and engineering work together, creating a marvel in the skies. Please like, share and subscribe. Thanks Explain for more such videos.